guys, I apologize. I got cut off in the middle of the chapter, or the problem 16 from section 8.6. And so we had been factoring this quadratic here, and we had combined our like terms so that we had 7x squared minus 26x plus 15 is equal to 0. So this is going to be one of our a times c factoring by grouping quadratics. So if I multiply a times c here, I'll have 7 times 15, which is going to be 105. So then I'm looking for factors of 105 that will add together to make negative 26. And so the two that are going to work in this situation are going to be negative 21 and negative 5. So I'm going to break apart this center piece to be 7x squared minus 21x minus 5x plus 15. And I'll set that equal to 0. Group my first two terms and my second two terms. I can bring a 7x out here, and I'll get x minus 3. And then I can bring a 5 out here, and I'll also get x minus 3. So then when I group, I'll have 7x minus 5 times x minus 3 is equal to 0. Then this solution will be x equals 3. This one, 7x minus 5, I'll have 7x is equal to 5. And then when I divide both sides, I'll end up with, oops, I slid off the page. I'll end up with 5/7 here. 5/7 and 3. Now this section told us that we need to go back and check our solutions. We have to check for extraneous answers. So what we want to do is take those two solutions and plug them back into the original equation. Now 3 is probably going to be a little bit easier to work with here, but we're definitely going to be able to do 5/7 as well. So let's check things out over here. When we take x equals 3, what I want you to do first is plug the 3 in to the 7x plus 1 divided by 2x plus 5. So use your calculator to plug that in, and you should end up with 2, and then the plus 1 comes along. So that's this term, and then we add 1. And then when I plug 3 in on the right, so I get 10 times 3 minus 3, divide that by 3 times 3, I get 3. So 3 is equal to 3. I'm good. This solution works. Then I also need to check x equals 5/7, which is a little bit trickier to plug in. So anytime you plug this in, make sure you put parentheses around the 5/7. So you're going to have parentheses for what happens up in the numerator and for the 5/7 that you plug in. So I'm going to have 7 times 5/7 plus 1. 7 times 5/7 plus 1. So that gives me 6. And then I divide that by 2 times 5/7 plus 5. And I get 0.9333. So 14/15 as a fraction. And then plus 1. And then, I'm just going to double check that once to make sure that I get the same thing both times. I didn't try to do anything funky with my fraction. Yep, okay, I get the same thing both times. Now I'm going to plug it in on the other side. 10 times 5/7 minus 3. And then I'm going to divide that by 3 times 5/7, making sure to work with my parentheses well. And I end up with 29/15. So this one I can change to be 15/15. And so if I add across here, I'll end up with 29/15 is equal to 29/15. So that works out. So 5/7 is also a solution. And I know that one is a little bit nasty. It doesn't have a great common denominator to work with, so things don't cancel out pretty. It's not the most fun quadratic to factor, and then plugging those back in is not easy. So this is one where you're definitely seeing all of the steps put together, but I'll try to make them a little bit friendlier for the ones that we do for tomorrow's review. Then our very last one is problem number 17, and I'm just going to do some erasing here so that way I have space to work through. So let's get rid of this work down here from the last problem. So just like up above, I want to make sure that I compare my denominators, and I'm going to multiply in with the denominators that I match to be the common denominator, so that way I'm working with easier expressions. So this x squared minus 1, I can factor to be x plus 1, x minus 1. So then when I check out my denominators, that is going to be the common denominator because one has x plus 1, one has x minus 1, and then the last one has both of them. So I'm going to have to multiply both of those terms into each expression, and that's going to get rid of all of my fractions. So over here and over here, I'm going to use x plus 1, x minus 1. So this is pretty similar to that complex fraction example up a few problems from this. So let's go ahead and distribute into this first term. So when I bring this here, I've got an x plus 1 up top and down below. So I'll have a 2x minus 1 here. When I distribute over here, x minus 1's up top and down below. So I will have just an x plus 1. And then over on the right-hand side, everything's going to cancel. So I will just have a 2 because all of this is both up top and down below. So let's distribute and combine like terms. We'll have 2x minus 2 plus x squared plus x equals 2. So let's combine like terms here first. I will have x squared plus I'm going to have 3x's here minus 2 is equal to 2. And then when I subtract this 2 over, I'll have x squared plus 3x minus 4 is equal to 0. And I can break this apart to become x plus 4 times x minus 1, because that multiplies to negative 4 and adds to 0. So my solutions here are going to be negative 4 and positive 1. Now we do want to go ahead and plug both of them back in, but the one that should draw our attention really quickly is this positive 1. This guy is not going to work because if I try to plug that in right here or right here, I would be trying to divide by 0. So if you plug this negative 4 back in, you will find that it works, but that the positive 1 is extraneous. So that is it for this review guide, you guys. We have some textbook practice that's linked on the website, and then we're going to keep studying and keep preparing so that way we feel really confident with all of the Chapter 8 material for Wednesday.